Okay, as mentioned before, when we're doing experimental studies, whether it's a true experimental design or a quasi-experimental design, there's going to be threats to validity. What does that mean? That means if there's somehow a flaw in the way I prepared the study, or actually conducted the study, or did my analysis, or chose my participants, it could jeopardize the results of all the hard work that I did to plan this experiment. So it's very important as a researcher that you carefully plan out your research study beforehand to make sure that any of these threats to validity are addressed prior to starting to gather data, or just prior to starting even selecting participants for your study. So some of the threats to validity, first of all, you could have internal validity. So my procedures, my treatments, or the experience of the participants that threaten interference in the experiment. So, when we're talking about procedures, you're talking about selection, my instrumentation, the setting. All these things could threaten the validity of my study. The treatments, is the intervention that I'm proposing, is it a sound intervention? Is it backed by literature? Is it backed by procedure? And if not, again, that's going to threaten the internal validity. And then the experiences of the participants, when things are happening, why they're happening, how much I've told them, all of those things are threats. And then there's external validity threats. So if I go through my study and I say, okay, I did this small study here, and now I want to generalize the results to a broader population, or to other populations, and if things aren't wrong, I cannot make those inferences to other persons or other settings or other situations. So if my design isn't tight as I'm doing it, it's just the results will just apply to this small sample that I chose, as opposed to being able to generalize to other people, settings, and situation. There's statistical conclusion validity. So we talked about power when we were doing surveys, and we talked, do I have enough of a sample size? Did I justify the statistics that I'm using? All of those things are very important. And also, I don't want to violate statistical assumptions. What that means is, no matter what statistical test I do, there are a set of assumptions that come along with that need to be met before I run that statistical test. So one of the most common one is normality of data, that my data must follow a normal, or at least semi-normal, distribution curve. If my data does not do that, then I am violating a statistical assumption of the test that I'm using, and it becomes invalid. Also, the type of data. Am I using nominal data? Am I using, is it nominal? Is it ratio data? Is it, as I'm reading this, but the data itself will determine what statistical test I'm going to use. Am I going to use parametric or non-parametric statistical analysis on it? And those things are very important, because if you use the wrong test, the wrong statistical test, then the results of your study are invalid. And then construct validity. Are there adequate definitions and measures of the variable? We talked a little bit about this when we were discussing the construction of the instrumentation. If I'm studying optimism and I'm really not using proper definitions of optimism, and I'm not measuring it correctly, and there's no construct validity within my instrument, then it really doesn't matter. And it really doesn't matter what the test I use, or how tight I am with the experiment, because I'm not measuring what it is I'm supposed to measure, or I'm measuring something completely different, which is another problem in and of itself. So those are the four types of threats to validity I could have. And then let's just look at a couple of these. The threats to internal validity. So I'm going to go back. Here are the threats. So we said procedures, treatments, or experience of participants can be threats. So the first one in that is history. So as you're doing an experiment, time will pass, right? So depending on when I do it and how much time has passed, a lot of things can happen to the participants, which, again, remember we said we want to eliminate all the other variables and just try to study one variable. But events could happen over the time that I'm conducting this research. So again, if we go back to the example of students in a classroom, there's 11 weeks, sometimes 15 weeks pass from maybe the time I give the pretest to the post-test or the intervention to the end of the class. So a lot of things could happen in there that could influence the outcome that I'm looking to get. So history could be a problem. So I want to make sure that if I have a control group and a treatment group, that they are kind of experience the same type of external events. So if something major happens, like a 9/11 or something over the course of my experiment, if both groups are experiencing this external event, then it kind of eliminates that threat to validity. But if only one group is experiencing it, it could impact, what happens on the other end of the experiment. There's maturation. Participants will mature over the course of the experiment. And this is particularly true of younger kids, if it's a longer study, maybe it's over the course of a year. Well, some are going to mature faster than others, and that could certainly have an impact on the results at the end. Regression to the mean is a very, very interesting one. And what that pretty much says is if you see there are certain groups who kind of get out in front of others and are kind of ahead of the curve, if you will, in terms of anything. And whether it's being able to, they're very good at playing basketball, or they have high levels of optimism, or whatever it is, for some reason they are kind of above and beyond maybe what the average would be. Well, regression to the mean is pretty much says that eventually that group is going to come back, or others are going to catch up to them to some degree. They're just so far ahead that it's normal that they would come back, or others would catch up to them. So that's a problem. So if I start off, let's just say we're measuring optimism, and we have some people who are way ahead of the others. And over the course of the experiment, we find that the ones who are lagging behind catch up. Well, that could be due to regression to the mean as opposed to the impact of my intervention. So that's something you have to really be aware of, these kind of outliers, these ones that seem to be way ahead of the others, because regression could certainly play a big role in what happens in the experiment. Selection is very important. We talked about random selection, but even if you randomly select, you want to just run some tests to make sure that you haven't inadvertently selected participants who are very similar. So if I'm doing, let's say I'm doing optimism again, and I'd say, okay, let me. I have my two groups. They were randomly selected. One's going to get a treatment, one's not. Let me go ahead and give them a pretest. And based on the results of those pretests, the averages of those pretests, I'll compare the two groups using something like a t-test and see if there's any significant differences between those averages of optimism. So I want to make sure that just by chance, by dumb luck, I selected in this group A, people with high levels of optimism, and group B, I selected people with low levels of optimism. Now regression to the mean is going to come into play, because maybe this high group and the low group will catch up. So that's definitely that could definitely be a problem. Mortality, people will pass away, people will drop out of the study. So if enough of people drop out of the study, it could jeopardize the results, because what if similar people are dropping out of the study? So for example, in my classroom experiment with performance, if a lot of the low performers are dropping out of the class, it might inflate the results of performance at the end of the class. So 5 or 6 students who wouldn't be doing too well and didn't do too well drop out, then my final grades might look a lot higher than they actually are. Diffusion of treatment is if participants in the control and experiment groups talk to each other about what's going on. So you want to isolate those two groups so one is getting a treatment and one is not. But if the people who are getting the treatment are talking to the people who aren't getting the treatment, the people who aren't getting the treatment might take up some of the techniques or tools or whatever that the treatment group is getting. So now all of a sudden I have kind of bleed over of my intervention into the control group, which is not good. Compensatory rivalry and resentful demoralization are kind of similar. It's if I'm in a control group and I'm not getting an intervention or treatment, and I feel that that treatment could benefit me, then I may become resentful of the treatment group, resentful of the institution, resentful of my organization, who's ever not giving me this intervention, and it could kind of throw off the results. I could bomb the test intentionally just because I'm angry or I'm resentful. So you want to really try to take steps to kind of create equality between the groups, make it seem like the control group, that they're getting something, that they're not just being not given something. Testing. We talked about pre-test, post-test. Well, participants may become very familiar with the pre-test, kind of memorize that, and then look up answers and then take the post-test and score very well. So the time between the pre-test and the post-test, how you're delivering, you might want to randomize the questions a little bit maybe, or increase the time between when you're delivering the pre-test and the post-test, just to kind of eliminate that testing variability. And then the instrument could change between the pre-test and the post-test. So if you're using a different post-test than the pre-test, maybe the answers are a little harder, or the questions are a little harder. Maybe they're not quite understood. So using the same similar instrumentation is good as long as you allow for enough time and again, maybe randomize the questions a little bit so it mixes it up a little bit. Then there are threats to external validity, and these are really, how am I able to generalize the results of my study? So the interaction of selection and treatment. Again, selection is always talking about the participants. Let's say I do a poor job selecting the participants to the study, then I can't generalize to other people, maybe because of the strict way that I selected my participants. So you want to watch about that. In the same way for setting and history. So based on the setting of where I conducted this research, I may not be able to apply that to other settings, maybe dissimilar type settings. And then of course, any research is time bound. So I'm doing it in a specific time, in a specific period, with specific events that are happening, a general feel of what's going on in the world, whether people are optimistic or whether not. So that's why we replicate studies a lot too, is so that I could perform the same study in different times, during different external events, so that the general mood of the country or the general mood of the world isn't influencing the experiment that I'm conducting. So those are threats to validity. Something you really need to consider when you're doing experimental designs, and you need to understand which ones may or may not surface as you're doing your experiment prior to conducting it, and then really come up with ways where you're going to address those potential threats in the design of your study.